So we've got a ramp that's a right angle triangle, and we know that they're going up this triangle at 12 meters per second. We're trying to find how fast is she rising. We're trying to find this at the moment right here when she leaves the ramp. So if we think of this triangle, here's our x, here's our y, here's our z, we know that all of those are going to be functions of time. Okay, well, we're gonna do it with calculus, and then if you want to try something with vectors. We tried just looking at some of the similar triangles and things like that, and it didn't work out directly. So here's the idea with calculus, and then if you want to see if you can find a way with vectors, that'd be great. So there's our triangle, and we know because it's a right angle triangle, we have this relationship. Now, as far as things go, x is a function of time, but we don't know dx dt. Y is a function of time, and we want to find dy dt. And z is a function of time, and we know dz dt is 12 meters per second. Now, taking the triangle that we have, the ramp is 1 meter here, 5 meters here, a squared plus b squared equals c squared, means the ramp is root 26 meters long. And this is going to use a similar idea that we did with our trough question and the cone question that we did after that. Right now, there's a problem in our equation in that we're good for z, we're good for y, because that's what we want to find, and we know what y is, but we've got a problem here with x, because we know what x is 5, but we don't know what dx dt is. And the only way we could find dx dt is if we knew what dy dt, and we don't know either of those. However, since we know there's a relationship between y and x, because no matter where we are on the triangle, it'll always be a similar triangle to this one. So if this is our y and this is our x, from here we can see that y over x will always fall in this ratio of 1 to 5. And then solving for x, we'll get x is equal to 5y. That means we can take our original x squared plus y squared equals z squared equation, replace the x with 5y, which will give us 25y squared plus y squared equals z squared. And now we've, adding those two together, now we've created an equation that's just with y and z. We know dz dt. We want to find dy dt. We can take the derivative with respect to time of this whole thing. We'll get 52y dy dt equals 2z dz dt. And we can just plug in everything that we know. We know that we want to find it when y is 1, so we're going to get 52 dy dt equals 2 root 26 times 12. And this reduces to 12, 6 root 26 over 13. So this one I think is a little bit tricky because you don't have enough information to start with that x, so it sometimes make you try to find another strategy for solving it, and it's in that going back and forth that you can get yourself lost.